Okay, so the information that we're going to go over this section, I know for a fact, having just taught pre-calc for the entire second semester, this is kind of the most important part of the second semester of pre-calc. And a lot of you are going to pre-calc. If you're moving on to geometry, you're going to use this too. So it's important that we have some understanding of some basic trigonometry. So the 6 words that I'm using, I've listed here: sine, cosine, etc. And then this symbol theta is a Greek letter, and it's just defining the angle. So instead of calling it angle A, they call it angle theta. And so the ratio, the sine of an angle is defined as the ratio of the opposite side to the hypotenuse. So I'm going to call it opposite over hypotenuse. The cosine of an angle is the ratio of the adjacent side to the hypotenuse. So adjacent over hypotenuse. And then the tangent of the angle is defined as the opposite over the adjacent. So if I was going to memorize something, I would memorize sine, cosine, tangent. So some people use the fact that the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent to spell out this SOHCAHTOA. So if you can remember SOHCAHTOA, then sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. And then the cosecant, CSC, is the reciprocal of the sine. So it is the ratio of the hypotenuse over the opposite. That's cosecant. And then the secant is the reciprocal of the cosine, so it's hypotenuse over adjacent. And then the tangent, or the cotangent, is adjacent over opposite. It's the reciprocal of the tangent. So if I can remember SOHCAHTOA, and then I remember which trig function goes with each, I can find the reciprocal. So number 1 says evaluate the 6 trigonometric functions of the angle theta. So I know that here theta is. So I know that the 12 is opposite, and I know that the 5 is adjacent. So I am going to need to use the Pythagorean theorem to find the hypotenuse. So the Pythagorean theorem, it doesn't matter which side's A, which side's B, but 5 squared plus 12 squared, the hypotenuse has to be C squared. So 5 squared is 25 plus 144 equals C squared. So 25 and 144 is 169 equals C squared. Take the square root because it's a side length. It only makes sense to be positive. So the hypotenuse is positive 13. So I know the opposite is 12, the adjacent is 5, the hypotenuse is 13. So I can find the 6 trig functions of this angle. The sine of theta is opposite over hypotenuse, which is 12 over 13. I'm just going to run through these. The cosine of theta, adjacent over hypotenuse, is 5 over 13. The tangent of theta is the opposite over the adjacent, which is 12 over 5. The cosecant, CSC, is equal to the hypotenuse over the opposite, but it's also the reciprocal of sine. So if I know that the sine is 12 over 13, I know that the cosecant is 13 over 12. And the secant is hypotenuse over adjacent, but it's also the reciprocal of cosine. So the reciprocal of 5 over 13 is 13 over 5. And then the cotangent of theta is the reciprocal of the tangent, or adjacent over opposite, which is 5 over 12. So finding the 6 trig functions is what I just did. Number 2 says, in a right triangle, theta is an acute angle and the sine of theta equals 4 over 7. Evaluate the other 5 trigonometric functions of theta. And I say draw a picture. Usually it's helpful to have it in front of us. So if I just draw myself a right triangle, it doesn't need to be anything special. And I'm just going to say right now it's not drawn to scale. And I'm going to put theta right there. I just picked to put theta there. They tell me that the sine of theta is 4/7. So I don't know the angle measure for theta, but I know the sine is 4/7. And I also know that the sine is opposite over hypotenuse. So from theta, I know that the opposite is 4 and the hypotenuse is 7. So I can find the adjacent using the Pythagorean theorem, and then I can find the 6 trig functions. So the adjacent, 7 has to be C. It doesn't matter if 4 is A or B. So 4 squared plus B squared equals 7 squared. So 16 plus B squared equals 49. Subtract 16. B squared equals 49 minus 16 is 33. And that makes B, I'm actually just going to call it the square root of 33. I'm not going to round. Now, something that I tried to do when creating your homework was not have any roots that simplified, but if that had some square, like if that had a perfect square in it, you'd want to simplify it, but I tried to avoid that. So, B is the square root of 33. That means the adjacent is the square root of 33. So I already know that the sine is 4/7, so I'll just go in order. The cosine of theta is the adjacent over the hypotenuse, which in this case is root 43 over 7. The tangent of theta is opposite over adjacent. So opposite is 4 over adjacent is the square root of 33. Now, I am going to need to rationalize the denominator, but I'm going to go back and do that in just a second. So I need to come back and rationalize the denominator for tangent. Cosecant is the reciprocal of sine, or hypotenuse over opposite. So if the sine is 4/7, the cosecant is 7 over 4. Hypotenuse over opposite. The secant is hypotenuse over adjacent, or the reciprocal of cosine. So if the cosine is root 33 over 7, the secant is 7 over root 33. Which then I am going to need to actually simplify that, rationalize the denominator, but I'm going to go back and do that in a second. And then we've got the cotangent. The cotangent is adjacent over opposite, or the reciprocal of tangent. And the reciprocal of 4 over root 33 is root 33 over 4. Okay, so now I need to go back and rationalize the denominators for tangent and for secant. So rationalizing the denominator means multiply by root 33 over root 33. So 4 root 33, and you can take 33 times 33 if you want to. When you take the square root of it, it's just going to be 33. So the tangent is that whole thing that does not simplify because one of the 33s is underneath the root and the other one's not. So 4 root 33 over 33. The secant needs rationalized as well, so I'll multiply by root 33 over root 33. So I get 7 root 33 over, again, when I simplify that, it's just going to be just 33, not with a root. So here, I'll go ahead and box the final answers for each of them. So the cosine, the tangent, the cosecant, the secant, and the cotangent. So just be careful with your typing of answers. And then there's some practice problems here. I'll start the next video with the answers to these, because this is a long video.